In our last class, we have learned what is eyepiece and what is the construction for the eyepiece and what is the definition for eyepiece. So now in this class or in this lecture, we are going to learn what is the Ramsdens Eye Piece. So we'll learn Ramsdens Eye Piece. So there is another eyepiece, that is Huygens eyepiece. So here let us learn what is the Ramsdens eyepiece. So let us start. This Ramsdens eyepiece will consist of two plano-convex lenses. So here you will have two plano-convex lenses. So let this be lens 1 and there will be another lens, so which will be kept at a distance far from the first plano-convex lens. So let's suppose this eyepiece is here. So this is eye lens. The total system forms the eyepiece. So now what you have two plano-convex lens, so which are kept coaxially, and the curved surface of the plano-convex lens should face each other. So you have plano-convex lens 1 and plano-convex lens 2, and these two plano-convex lens curved surface is facing each other. So if you observe, this is the curved surface for the first lens and this is the curved surface for second lens. So these two faces are facing each other. So now what will be there before the eyepiece? So before eyepiece we will have objective lens. So the rays which are coming from the object which is kept at infinity will come and fall at the objective lens, and the image will be formed before the eyepiece. So let's suppose this image here is the image of the objective lens. So this is the image for the objective lens, and this here forms the object for the plano-convex lens 1, or this will be act as a object for the eyepiece. So now there will be the rays which comes from this image. So there are basically two rays that comes from the image of the objective lens. So these two rays, after falling on the first plano-convex lens, will get refracted and falls on the second plano-convex lens of the eyepiece. So these rays which are here will pass through the second plano-convex lens, and these two images or these two lines after refraction will be parallel to each other. So now what happened? The image of the objective lens is the object for the eyepiece, and now the rays from the image will fall on the first plano-convex lens and gets refracted. So these two rays again goes and falls on the second plano-convex lens, and these two rays gets refracted again and they emerge out as a parallel rays. So parallel rays will meet at infinity. So let this be I. So I here is the image of the objective lens, and this image which is formed here is the real image of the object. Now if you extend this rays then these two rays meet at a point, so that forms the virtual image. So let this be I1. So if you extend the two refracted rays from the first plano-convex lens, then these two rays meet at a point and that forms the virtual image. So why this is virtual image? Because if you see, these two rays are not the real rays. So these two rays appears to meet at this point. So hence this is the virtual image and this is the real image. And this virtual image here can act as the object for the eye lens. So this is eye lens and this is field lens. So this is field lens and this is eye lens. So virtual image which is formed here can act as a object for the eye lens. So in eyepiece you basically have two lenses, field lens and eye lens. Field lens will be near to the objective lens and eye lens will be near to the eyes. So from here to the eye lens, it is the focal length, so actual focal length. And the separation distance for these two lenses should be equals to 2 by 3f. So this is constant. 2 by 3f should be the separation distance between the two plano-convex lenses which are used in the Ramsdens Eye Piece. So what happened here is the objective forms an image at a distance, object at eye. The eyepiece forms its final image at I1. Eyepiece will form the final image at I1 and the objective lens which is present before the field lens will form the image at I. Now let us find what is the object distance for this plano-convex lens. So that is the distance between the eye and the plano-convex lens 1. So that you can do by using the lens formula. 1 by u minus 1 by u will be equal to plus 1 by v. So one minus 1 by u plus 1 by v will be equals to 1 by f. So v we know. So v can be found from the diagram. So f minus 2 by 3f is f by 3. So this distance, v distance is f by 3. So if you subtract 2 by 3f from f, you get the f by 3. So if you substitute that in the equation, then you get minus 1 by u plus 1 by minus f by 3 is equals to 1 by f. So this can be written as 1 by u minus 3 by f, which is equals to 1 by f, and minus 1 by u is equals to 1 by f, so plus 3 by f. So this will become 4 by f. 1 by u is equals to 4 divided by f. So u will be what? U is equals to minus f by 4. So the image distance is at f by 4. So the negative sign represents it is in the opposite direction. So this distance from here to here is f by 4. So we found what is the object distance. So that came around the f by 4. Here if you observe, the field lens is bigger when compared to eye lens, because this is made bigger because to let more rays to pass through the field lens such that we can have the brighter image. So final image will be brighter, so if you make the field length larger. So the field length larger means the intensity of the light will be more. So intensity means the number of rays or light rays that are present. So if more number of rays are present, then intensity will be more. So if less number of rays are present, then intensity will be less. So to let in more number of rays, the field length is made larger in size compared to eye lens. These curved surfaces which are facing to each other can actually minimize the spherical aberration that occur. And now let us learn what is equivalent focal length. So what will be the equivalent focal length for the Ramsdens Eye Piece? So F, capital F, denotes the equivalent focal length or equivalent focal length for the system of lens. So 1 by F can be written as 1 by F plus 1 by F. So let this be F1 and this be F2 minus D divided by F1, F2. So this is the equivalent focal length. So 1 by F is equals to, so these two lenses has the focal length same, so that is F plus F minus, so D is separation distance, so that is 2 by 3F, so F into F, F square. So F will get cancelled. What remains is 1 by F is equals to 1 by F plus 1 by F minus, so 2 by 3F. So now this can also be written as 1 by F is equals to 2 by F minus 2 by 3F. So now if you take the LCM for 2 by F minus 2 by 3F, then what you will get? 1 by F is equals to 3 to 6F minus 2F divided by 3F square. So 6F minus 2F is 4F divided by 3F square. So F will get cancelled. What remains is 4 by 3F. So that means 1 by F is equals to 4 by 3F, and F, that is equivalent focal length, will be how much? 3F by 4. So this is the equivalent focal length for the system. So how did we do that? We used the equation for the equivalent focal length. So that is 1 by F is equals to 1 by F1 plus 1 by F2 minus D by F1, F2. So substituting the focal length for the two lenses. So for two lenses the focal length is same, F and F. So 1 by F plus 1 by F minus 2 by 3F divided by F square. So if you solve this, then you get finally this 6F minus 2F by 3F square. And again if you solve this, then you get 4 by 3F, and if you take the reverse of this, then you get the equivalent focal length. So we found what could be the equivalent focal length for the Ramsdens Eye Piece. Now let us learn what will be the position of equivalent lens. So here if you want to set the equivalent lens, then what can be the position? So we got to know F is equals to 3F by 4. So this is the equivalent focal length. So this will be placed behind the field lens. So alpha will be what? dF by F. So we know what is D. So from the diagram, D is equals to 2 by 3f, and f we got to know that is 3 by 4f, and f we don't know. So alpha can be written as D 2 by 3f multiplied by f is 3f by 4, and now this should be divided by f. So if you write 3 2s 6f square divided by 4 3s 12, and this whole divided by f. So 6 1s 6 2s, f will get cancelled. What remains is f by 2. So alpha here is f by 2, that is alpha denotes the position of equivalent lengths. So let us draw this in a diagram. So alpha has f by 2 distance. So equivalent length lies between the field length and the eyepiece, and this distance from here to here we got it as f by 2, and this is the position for the equivalent lengths. And this eyepiece can also be said as the positive eyepiece because it is magnifying the real image that is formed from the objective lens. So hence we can call this as a positive eyepiece. So what positive eyepiece means? So this eyepiece is magnifying the real image that is formed from the objective lens.